question number 10. Question 10, which of the following is false concerning circuits? A, the voltages in a series circuit add up. B, the currents in a parallel arrangement add up. C, the resistance total in a parallel is the sum of the individual resistances. D, the total power dissipated in each resistor must equal, there's equal there, the power generated by the battery. E, the resistance total in a series arrangement is always greater than each resistance. So all of these questions had to do with resistors and the way that they are arranged in series parallel. A series arrangement is where you have resistors end to end. In a series arrangement, the current is the same. I total equals I1 equals I2. And I have talked about this in previous videos too, so I'm not going to go in great length through this. The voltages add up. V total is V1 plus V2. And also the resistance adds up. R total is equal to R1 plus R2. In parallel arrangement, parallel is when basically to form a parallel circuit, you close the circuit with one of the resistors, and then you connect the other resistor, R2, across the R1. So parallel means one resistor itself closes the circuit already. And then you can put as many resistors in parallel as you want. In series arrangement, one resistor by itself doesn't close the circuit. You go from the end of the first resistor to the second resistor. From the second resistor, you can add a third, and a fourth, and a fifth, and then you close the circuit. So you need all of them to be part of the circuit in order for the circuit to be closed. In here, the voltages of each one are the same. The voltage total of the battery is equal to V1 equal V2. The current adds up. I total is I1 plus I2. So the total current coming here splits into the first circuit and the second circuit, this first branch and the second branch. So I total, you have I1, you have I2. So the current splits up into two. And if you had three branches, it would split up into 3 and 4 and so on. Okay, how does the resistance add up in parallel? You have 1 over R total equal 1 over R1 plus 1 over R2. So let's see which of this is false. A, the voltages in a series circuit add up. Series voltages adds up, that's true. B, the currents in a parallel arrangement add up. The currents in parallel add up, right? This is parallel. C, the resistance total in a parallel is the sum of the individual resistances. The resistance total in parallel is the sum of the individual resistances? No. It should say the reciprocal of the resistance total is the sum of the reciprocal of the individual resistances. Let me word that again. The reciprocal of the resistance total is the sum of the reciprocal of each resistance. Okay? So that is false. C. C is the answer. D, the total power dissipated in each resistor must equal the power generated by the battery. Yes, conservation of energy. Whatever energy the battery is providing, that energy must be lost in the resistor and the other resistor in form of heat or light energy. Okay, so conservation of energy. So D is true. E, the resistance total in a series arrangement is always greater than each resistance. Yes. It's the sum of the two resistors, so either resistor by itself, you add them up, you're going to get a greater. So the resistance total in the series arrangement is always greater. It would have been also true if it had said the resistance total in a parallel arrangement is always less than each resistance. That's true too. Since you're taking the reciprocal of each resistance and adding them, and then you're reciprocating that, you're always going to end up reducing the net resistance of the circuit, because the current has two choices to come down to each branch. So effectively the two resistors next to each other are decreasing the total resistance of the circuit, right? So if it had said the resistance total in parallel is always less, that would have also been true. So C is the one that is false. Okay, thank you very much.